Hey class, this is Professor Fowler, and this is a short video concerning air traffic control communications. Typically, when pilots and controllers communicate, it's on the radio, and it's on the very high frequency band, or VHF band. The problem with the VHF band is that it's limited to line of sight. What does that mean? Basically, if there are mountains, a mountain range, tall buildings between the transmitter and the receiver, then there could be problems receiving the transmission. Pilots and controllers need to learn what's called the phonetic alphabet, and the reason for that is because many letters in the alphabet sound the same. For example, the letter N sounds the same as the letter M. So instead of saying A, B, C, or D when talking about letters, pilots and controllers should use a phonetic alphabet: Alpha, Bravo, Charlie, Delta, so on and so forth. That just makes things clearer, reduces confusion. For example, if you're telling a controller your identification number, your tail number, instead of saying N582MT, and notice that the N and the M sound very similar, the pilot should say November 582 Mike Tango. That makes it more clear, less confusing. Another example is N71SB should be said November 711 Sierra Bravo. One of the services available from air traffic control is called traffic advisories, or some pilots call it flight following. If you want flight following or traffic advisories from air traffic control, then you call an air traffic controller and simply request flight following or traffic advisories. They'll give you what's called a squawk code. The squawk code is simply the code that you are required to dial into your transponder in order to get the flight following. Once you dial that code into the transponder on your aircraft, the code is delivered to the air traffic controller's radar screen so that they can identify you and they can warn you about any oncoming traffic. If you're not talking to a controller, though, you're in uncontrolled airspace and you're not under the control of any air traffic control facility, you should be squawking 1200 in your transponder. That's known as the VFR squawk code. Some codes to avoid in your transponder, though, are 7500. That code is for hijacking. 7600 is for lost radio communication. So if your radio stopped working, but you still have your transponder working, you can dial in 7600 to let air traffic control know that you have lost your radios. 7700 is an in-flight emergency. So if you're having an emergency, one way to tell air traffic control that you have a problem is to squawk 7700 in your transponder. And that also enables them to locate you quickly. And if you're ever intercepted by a military aircraft, they'll tell you to squawk 7777. Hopefully that never happens to you. When an air traffic controller warns you about oncoming traffic, they'll tell you to look in a direction that corresponds to the clock, an analog clock. So for example, they may say traffic at 12 o'clock. That simply means that traffic is straight ahead. They could say traffic is at 3 o'clock. That means traffic is off your right wing. Traffic at 6 o'clock means that the traffic is behind you, and traffic at 9 o'clock means that the traffic is off your left wing. This could cause a problem, though, because the only thing that a radar controller can see on their screens is your ground track. They can't see which direction your nose is pointing. And your nose may not be pointing toward your ground track because you may be adjusting for wind. For example, if you have a wind from the right side, you may be pointing your aircraft to the right into the wind in order to maintain your ground track. So if the air traffic controller says traffic at 9 o'clock, instead of 9 o'clock, you should probably look more at the 8 o'clock point to find the traffic. Radio phraseology is a language all in its own. It's not similar to citizen band or CB language or ham radio slang. You should use very specific letters and numbers, and there are specific rules that you should follow when you're communicating altitudes to air traffic control. Altitude should be stated in separate digits, in thousands plus hundreds. So for example, if you're at 4,500 feet, you should state 4,500, not 4,500. 10,000 and above is a little different. You should say that you are at 500,000 if you are at 10,500 feet. Another example is, instead of 13,500, say 13,500. Another service available from controlled airports is called ATC, or Automated Terminal Information Service, and this is designed to reduce frequency congestion. There is a recorded message that you can hear on a certain frequency at controlled airports, and it's recorded hourly, and it's available to all pilots who are either departing the airport or approaching the airport. Information like the ceiling, cloud ceiling, visibility, the wind, altimeter setting or barometer, temperature and dew point, active runways. So you can listen to this before you contact the controller if you're flying to the airport, and that enables the controller to avoid having to tell you this every time a new pilot contacts them. You not only need to contact a controller at a controlled airport in the air, you also should be talking to a controller while you're on the ground, because you can't just taxi at a controlled airport. You need a clearance, and that's to avoid any conflicts in taxiing traffic. For example, if you're ready to taxi to your runway to depart, you could contact air traffic control on the ground frequency. And if they said something like you're cleared to taxi to runway 30, then you are cleared to taxi all the way to runway 30. You can cross any intersecting taxiways, any intersecting runways without stopping, unless they tell you to hold short. That does not mean, however, that you can taxi onto the runway. Once you get to runway 30, you should hold short. Once you get to the runway, you may hear the term line up and wait. That simply means that you can taxi onto the runway, line up with a center line, and then wait for your clearance to take off. Controllers will do this at a controlled airport to expedite traffic, keep traffic flowing. After you land at a controlled airport, it's important to stay on the tower frequency until the tower controller tells you to switch to ground. And most ground frequencies start with 121. So an example for ground frequency at many airports would be 121.9 or 121.9er. You may hear a controller say contact ground on 0.9er. That's just short for 121.9er. At uncontrolled airports, you still should be talking on the radio if you're equipped, and that's done typically on what's called the Common Traffic Advisory Frequency, or CTAF. Some examples of frequencies at uncontrolled airports are the CTAF. Unicom is a frequency that you can contact at some airports, and that typically is to get airport advisories. Someone at the airport, maybe working at the FBO or fixed base operator, will answer your call on the Unicom and tell you what the wind is, tell you what the active runway is, give you any information that you need about the airport. Other examples are Multicom, which is a combination Unicom and CTAF, and AWOS is kind of like ATC. It stands for Automated Weather Observation Station. If the airport has an AWOS, then you'll hear a broadcast on a certain frequency concerning the weather, ceiling, visibility, wind, so on and so forth. You can find the CTAF frequency by looking for the airport on your sectional. And when you find the airport, there's identifying information, and the frequency with a C to the right of it is the CTAF, or Common Traffic Advisory Frequency. Now, the Common Traffic Advisory Frequency should be used to give other pilots who may be in the pattern or are getting ready to depart that airport on the ground an idea about your intentions, about your location, so that they can look for you and avoid conflicts. Another service available is a flight service station. One thing that to keep in mind is the flight service station is not air traffic control. They are there to give you information, for example, standard weather briefing before a flight. They can tell you about temporary flight restrictions, any NOTAMs that have been filed for an airport. For example, if an airport has a runway closure, you can find that out from flight service before you depart. Some airports have flight service stations on their field, and if that's the case, an area 10 miles around that airport is known as an airport advisory area. And you can call a flight service station for airport advisories. You can find out about the flight service station that handles your area by looking for VOR identifier box on the sectional. When you find the VOR identifier box, the flight service station that handles that area should be indicated below the box. And the frequencies that you can use to contact the flight service station should be on top of the box. Another service, if you ever lose your radios, the ability to use your radios, there are certain lost communication procedures that you should follow. If you're in uncontrolled airspace or an uncontrolled airport, radios are not even required at an uncontrolled airport, so you just should remain vigilant about traffic and land as soon as possible. If you're approaching a controlled airport or you're flying out of a controlled airport, you should probably squawk 7600, 7600 on your transponder. That lets controllers know that you are unable to use your radios. You can also declare an emergency. If you have an emergency, tell the air traffic controller, if you're already talking to ATC, that you would like to declare an emergency. That gives you priority handling. In other words, if you need to land right away, any other traffic in the pattern should give way to you because you have priority. If you're not talking to ATC, there's a specific frequency that you can use. 121.5 is known as the guard frequency, and that's just to be used for emergencies. If you're ever lost, you should use the 5 C's: climb, communicate, confess, comply, and conserve. Climb because you want to be as high as possible. If you're lost, altitude is your friend. It'll enable you to see more landmarks and you may recognize something. If not, communicate with ATC and confess that you're lost and that you need help, and then comply with whatever ATC tells you. And the last C is conserve. Conserve fuel because it may be a while before you can land. Now, most pilots know that they can file a VFR flight plan on a VFR flight. It's not required, but it's always a good idea if you're going on a flight to file a VFR flight plan. And the reason is because if something should happen, then and you don't arrive at your destination airport as planned, the flight service station will initiate search and rescue operations. If you don't file a flight plan, then it could take a while before search and rescue operations are initiated. VFR flight plans can be filed over the phone. The number to reach the flight service station in your area is 1-800-WX-BRIEF, or you can file a flight plan on the 4Flight app on your iPad. Filing a flight plan and opening a flight plan are two different things. You file over the phone with the flight service station, and then you can open your flight plan before you depart on the phone or after you depart on the radio. The flight service station, when you're filing the flight plan, needs specific information about your flight and your airplane. They'll want to know if it's a VFR or IFR flight. They'll want to know your airport identification number, the type of equipment that you have. For example, if you're equipped with GPS, then the equipment code is Golf or G. Your true airspeed, your departure point, your en route time, your cruising altitude, your route of flight. Once they have all of this information, they'll file your flight plan and you can open it after you depart. Aviators use very specific time. They use the military time or the 24-hour clock. They also speak in terms of what's called UTC or Universal Coordinated Time. Some pilots and controllers will call that Zulu time. And you will see UTC time on weather reports, for example. UTC time is simply the time in Greenwich, England. And the whole world is divided up into 1-hour time zones. Exactly one hour in each time zone. So in the US we have 4 time zones: Eastern, Central, Mountain, and Pacific time. Each of them 1 hour apart. Again, aviators use the 24-hour clock or military time, so 1 o'clock in the morning is 0100 hour, 6 o'clock is 0600, 12 noon would be 1200, 1 o'clock in the afternoon is not 1 o'clock, it's 1300, 1400, 1500, so on and so forth, all the way up to 2400. To convert local time to UTC or Zulu time, you need to add a certain number of hours based on the time zone that you're located in. So if you're in the Pacific Standard Time Zone, you would add 8 hours to Pacific Standard Time to convert to Zulu time. In the Mountain Time Zone, you would add 7 hours. Central Time, like here in Tennessee, you would add 6 hours. And on the East Coast, Eastern Standard Time, you would use or add 5 hours. So that's the presentation on ATC communications. I'll be posting a PowerPoint presentation. You can review that information as well. And if you have any questions, you can email me. I'll also post a couple of videos that you can watch, which will give you additional information about how to communicate with air traffic control. Thank you.